What's the matter? Can't sleep?
Just need a little clarity.
True that. You want the customary clarity or the new and improved kind of clarity?
Just give me the new stuff.
New and improved. New and improved clarity. Yes, indeed, clarity.
Come on.
Here's one.
Yeah, don't bust my balls. You're gonna give me 4 and some of these duds.
Sweet dreams, Chief. Don't worry, none of your secret's safe with me. Besides, I could use a little juice on my side.
What do you think you know, Micah?
It's like my daddy used to say, in the land of the blind, the one-eyed man is king.
Michio Kaku, what is the theory of everything?
The theory of everything is what drives hundreds of physicists around the world. And it could be the crowning achievement of 2,000 years of our investigation into the nature of matter. We want an equation, 1 inch long, that will allow us to, quote, read the mind of God. We want an equation that will summarize everything we know about the universe. Gravity, light, the electromagnetic force, the nuclear force. We want all of it into a single equation, which will give us not just the Big Bang, the formation of planets and galaxies, but even the formation of people, maybe even love. All of it in a theory that eluded Einstein for the last 30 years of his life. And today, we think we have it.
We do.
Yeah.
Why do we think that?
Because we have a theory called string theory. It is fantastic. It is incredible. It has astounded the world of mathematics and physics. And now you can't move in the physics world without bumping into somebody who wants to talk about the 10th dimension, the 11th dimension, the multiverse, hyperspace, time travel. All the things that were once considered science fiction are now centerpiece in our understanding of the nature of everything.
You called it a theory, however.
It's a theory because we are going to test it with the Large Hadron Collider. You know that Big Bang machine outside Geneva, Switzerland, that some people think is going to tear the world apart? Wrong. It's a machine of science. And we hope to create a mini Big Bang by slamming protons together near the speed of light, recreate a teeny weeny bit of Genesis, and from that, extract information that will show us that perhaps string theory really is a theory of everything. And that's what I do for a living. That's my day job.
Where did string theory come from, and who's the founder of it?
You're not going to believe this. In science, we always say that you make observations, you have a theory, you go make more observations, and it's a very, very tedious process. Wrong. Nobody that I know of in my field uses the so-called scientific method.
Come on, don't bullshit me.
No, I'm telling you, Doug, your brain will not know the difference. And that's guaranteed, or your money back.
I work at Goldsmiths. I'm the director of the Magic Lab. And in the Magic Lab, we try and use magic as a way of studying the human brain, because magicians have developed very powerful techniques that allow them to manipulate your experience, and they can hijack your brain. And by understanding some of these principles, we can learn a lot about how the brain works. And so as a scientist, I'm interested in both the techniques that magicians use, as well as the experience that magic elicits. And so what is magic?
This is just one of the strange results that comes out of the general theory of relativity, our current best theory of gravity. The first solution of Einstein's equations predicted not only black holes, but also their opposite, white holes. It also implied the existence of parallel universes and even possibly a way to travel between them. This is a video
about the real science of black holes, white holes, and wormholes.
Could black holes be the key to a quantum theory of gravity, a deeper theory of how reality, of how space and time works? Black holes are interesting because we have a place called the event horizon, where we think that we have full control of the physics. We understand what's happening, but there is a fundamental clash between our two basic theories of nature, both quantum theory and general relativity together.
So the first wormholes that were imagined were a black hole connecting to its mathematical opposite, a white hole, and you would connect them via a wormhole. So everything goes in the black hole and comes out the white hole. It's mathematical opposite. But then there's more work done on wormholes, especially inspired by Carl Sagan's novel Contact, when he was buds with Kip Thorne, a relativist physicist, astrophysicist at Caltech, where you run through more of the equations, and you can, in principle, just punch a wormhole through the fabric of space without reference to a black hole or a white hole. But you need some way to pry open space and keep it there. So you need like negative matter that can pull open space rather than collapse space. And so that works, our equations give it to you, but we don't know any substance such as negative matter. So wormholes are really just, for now, the realm of science fiction. Black holes, there's some mathematics derived from Einstein that tells us that inside a black hole, it opens up to another universe, another space-time system. And so if that's the case, what happens to that universe when the black hole evaporates?
Nice. Whoever was smoking weed in that universe sobers up and it's over. That little universe is gone. I saw that universe before. I can't believe I saw this universe, man. It was just right there in my thumb.
So you're going to write a book, The Universe According to Weed. Is that what you're...
Yes. It's a good book. I'll call it Astrophysics for Stoners in a Hurry.
But another description of the event horizon, which confused people all the way through the history of black hole research actually, was the idea that the event horizon, when viewed from the outside, is a place in space where time stops. Now that's a direct prediction of Einstein's theory of relativity from the external perspective.
The general theory of relativity arose at least in part due to a fundamental flaw in Newtonian gravity. In the 1600s, Isaac Newton contemplated how an apple falls to the ground, how the moon orbits the Earth and Earth orbits the sun, and he concluded that every object with mass must attract every other. But Newton was troubled by his own theory. How could masses separated by such vast distances apply a force on each other? He wrote that one body may act upon another at a distance through a vacuum without the mediation of anything else is to me so great an absurdity that I believe no man who has a competent faculty of thinking could ever fall into it. One man who definitely had a competent faculty of thinking was Albert Einstein, and over 200 years later, he figured out how gravity is mediated. Bodies do not exert forces on each other directly. Instead, a mass like the sun curves the space-time in its immediate vicinity. This then curves the space-time around it, and so on all the way to the Earth. So the Earth orbits the sun because the space-time Earth is passing through is curved.
What is gravity?
I have no idea. Okay, next question.
Wow.
No, here's the difference. We can describe gravity. Okay. We can say what it does to other things. We can measure it, predict with it. But when you start asking, like, what it is, I don't know.
Kowalski. Sorry, sir, no clue.
So what will be the force pulling a heavier object to the ground and an air bubble up? How can a force work in two directions at once? That wouldn't make any sense.
No, I see what you mean.
That's why there's no force going down. That's why Einstein had to come up with his explanation of the bending and warping of space-time. That's just a theory, by the way. It's not reality.
Every description is a theory, right? No.
Not if you could demonstrate it.
No. Okay. You have to not confuse the word theory with hypothesis, right? Well, in science, a theory is simply a testable description of reality. A hypothesis is a guess that could be wrong, could be incorrect. The layman, right, conflates the two.
Right.
And they are totally different, distinct concepts.
So what about, what do you think
of just a theory? What people actually mean is just a hypothesis.
What do you
Relativity is not a hypothesis. It is a theory that has been tested time and again.
So what do you think about the scientific theory? No, not scientific, scientific method. What do you think about the scientific method?
I have yet to come across a more reliable methodology for acquiring knowledge from the environment.
I would say the scientific method is a method that's used to prove things. For example,
I would say you cannot prove things.
I could prove that we could build cars.
You can demonstrate it.
Well, we could get in a car and drive it. It physically exists.
Yeah, but if you want to be technical, proofs can only be done in the realm of mathematics. Okay, you can demonstrate things in reality. In science, you can only disprove a theory. General relativity is a legitimate, is the description of space.
Right. But I can't prove that steel is stronger than wood.
Yes.
Would you deny that or no? We obviously have to accept that steel is stronger. I could physically,
you can demonstrate.
I could physically, scientifically prove that steel is stronger than wood.
Different types of things, right? One is
stronger than the other.
No, I'm talking about the demonstration that
I can demonstrate to you that steel is stronger than wood.
Let me finish. The demonstration that steel is stronger than wood, right? Proving that is different than applying the word proof to a scientific theory. You cannot prove any scientific theory.
Yeah, because it's a theory. I agree. Yeah.
But because it is a. You can.
So you disregard their scientific facts. You disregard that. You don't believe that they're scientific facts.
I do. Scientific facts and scientific theory are two different things.
So explain to me what a scientific fact is.
A scientific fact is just simply an observation.
Give me an example.
Okay, that the strength of the gravitational force, on average, right, on the surface of this planet is 9.81 meters per second squared.
Okay, I would say that's an observation.
That's a fact.
I would say that's not a fact.
What is the difference between observation and a fact?
An observation is something that you just simply observe. For example, we can observe this pole, and I can
repeatedly.
No, I can just by looking at it, I can tell you it's 20 feet tall. But that's not fact. The fact will be physically measuring it to see how tall it is. So
I gave you an example of a measurable fact.
No. When you're observing something fall, you believe that the object goes towards the ground, first of all, right? That it's being accelerated towards the ground.
Yes.
I'm telling you that physics shows that that's not what's happening because you need force to cause motion. So if you're claiming that this...
You don't need force to cause motion.
Can you show me an example of something moving that doesn't require a force? Well, that's a theory. I need something in reality. Like something here on Earth. Can you show me something that's moving that doesn't require a force here on Earth? No, because again, motion requires a force. So if you're claiming this is motionless...
That's not the reason I can't show you. The reason is I cannot manipulate space.
Well, that's because you're going into the bigger scale of things.
Exactly. Yeah.
You're going into imaginary physics.
It's not imaginary.
Because it cannot be demonstrated here on Earth.
But it doesn't... Just because something cannot be demonstrated in front of you doesn't mean it's real. It's not real. Right? Well, I can't observe galaxies. So it doesn't mean that other galaxies don't exist.
So you believe that flying reindeer are possible then? Because you can disprove that, I guess, or whatever?
No.
Or do you have any...
That's an excellent question. Now we're getting into epistemology and ontology and the very concept of belief. So, technically, I have no choice but to be agnostic. I can hypothesize that flying reindeer exist, but it's on me, it's my responsibility to demonstrate that they exist, right?
Exactly,
but I cannot technically say they do not exist.
I could. I trust my common sense, and a reindeer is more denser than the air, and the air will never be able to sustain a reindeer. It would be impossible.
You cannot state that. You cannot say, conclusively. You have to demonstrate. Okay.
That defies physics. Anything that defies physics, in my opinion, I don't accept.
Physics, the way we... Okay, so there's two types of physics. There's physics, there's the laws of physics that we humans have constructed as a theory, as a description of the actual reality.
Right?
Yeah. But these are two distinct things. There's how reality actually operates, and then there is our
in our
scientific method. Yeah,
our interpretation.
Yeah, our the utilization of mathematics and consistent repeated observations, right, to construct a theory or discover a law, right?
Yeah.
That is consistent under certain assumptions and approximations, right? Okay. For example, relativity, even Einstein admitted this, is incorrect at the quantum scale. It is a classical theory.
Okay, sure.
By construction,
it
is wrong.
Yeah.
Everything is wrong. But it doesn't.
Everything about the heliocentric model is wrong. Yeah, because
no. Every description that you have, that I have, that every human has, is wrong.
You should have bought a gun instead of a beer, mate.
Nah, I don't need a gun. I've got a donk.